Hey guys, Mr. Wilson here. Today we're going to talk about simplifying radicals with fractions. At the end of this video, you should be able to simplify radicals involving fractions, and you should be able to rationalize the denominator of a fraction. Alright, so let's start. Alright, we've already talked about simplifying radicals where we had just numbers, and we did that using the number tree kind of factorization method, where we just found two numbers that multiplied to give us 52. Okay, and we did that all the way until we were all the way down to our primes, and then we take pairs out, and so radical 52 simplifies to give us 2 radical 13. Okay, we could do the same thing when we had variables, p to the 7th, n to the 10th. Remember with these, so it might be helpful to separate these if you want to. Maybe at this point you're like, nope, no need to separate them. That's fine. And then you see, how many pairs do I have in 7? Well, I have 3 pairs, so p cubed. I have 1 that doesn't have a pair. How many pairs do I have in 10? So n to the 10th, that means I have 5 pairs of n. So n to the 5th. Then I have my outside numbers. I'll write on the outside, so p to the 3rd, n to the 5th, radical p. And that's my final answer. Okay? So now we're going to talk about division properties of radicals. Okay, so you see that radical a over b is the same as radical a over radical b. Okay, and this is going to be helpful for us in rewriting these and simplifying things. And this is how we can use this. We have radical 9 over 25. Now the problem looks confusing because we already don't like fractions very much, but let's see how this works out. Radical 9 over radical 25 can be written as radical 9 over radical 25. Okay? We can find radical 9. Radical 9 is 3. Radical 25 is 5. And so, see, these are perfect squares. We have 3 over 5. Okay? We can do the same thing with number 2. So we have radical x to the 5th over 16. We are going to write it as radical x to the 5th over radical 16. So I'm going to simplify x to the 5th. I know I have 2 pairs of x's and 1 left over. And then 16, that's just 4. So my final answer is x squared radical x over 4. Alright? Rule with the radicals is you can never have a radical in the denominator of a fraction. Okay, in the bottom part of our fraction, we can't have it. It's okay to have it in the numerator, as you see in the second one. We can't. In the 2 examples above, do we satisfy this rule? Yes. Why? Because there were perfect square numbers in the denominator. Okay, 25 is a perfect square, 16 is a perfect square. Alright, in this next problem, is the number in the denominator a perfect square? No. Okay, remember when we say perfect square, we're saying a number that can be multiplied, a number can multiply itself to get to that number. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So 1, 4, 9 are perfect squares. Okay, 12 is not a perfect square. So what do we do then? Well, the inside of the radical is a fraction, and all fractions can be simplified. So we'll try to simplify it. Or reduced. And once we do this, this new fraction in the radical is, so let's see, can we reduce this? So we look, we say, is this a perfect square? No. Okay? And then we say, well, can we reduce it? In this case, we can. I know that I can take 3. Okay? And that changes this to 25 over 4. So the new fraction now is 25 over 4. And now we can do our radical thing, which will be radical 25 over radical 4. Okay, which will give us 5 over 2. Alright? So if we had a perfect square, we could just simplify that way. If we don't, we reduce first and then try to simplify. Alright, let's do some more problems. So we have radical 15 over radical 27. Again, remember that this radical 15 over radical 27 can be written a couple different ways. That's the same as writing radical 15 over 27. Okay, so now you see the fraction a little bit better. Okay, the denominator is not a perfect square, so if it's not a perfect square, denominator is not a perfect square. Okay, so since the denominator is not a perfect square, we're going to try to simplify. I know that in 15 and 27, 3 goes into both of those. So I have radical 5 over radical 9. Okay, so now in my denominator, radical 9 is 3. So I can say radical 5 over 3. And there you have it. That's the answer. Okay. Number 2, same thing. I check the denominator. I say, is this a perfect square? Nope, 18 isn't a perfect square. X to the 9th isn't a perfect square either. So we'll simplify. What goes into both of these? Well, 100 and 18 are both even, so I'll take out 2. 50 over 9, okay. X to the 3rd and x to the 6th, I'm just going to simplify this, and I'm going to do that by subtracting that 3, so I get x to the 6th in the denominator. Alright, so now I have radical 50 over radical 9x to the 6th. Okay, radical 9 is 3. Radical x to the 6th is x to the 3rd. And then radical 50 can simplify to 25 and 2, 5 and 5. So I have 5 radical 2. And there's my final answer. Now when I'm done with that, I'll make sure that I cannot simplify this anymore, but I can't. 5 and 3 don't simplify any. Okay? Alright, so what happens if the number in the denominator is not a perfect square and simplifying the fraction doesn't give a perfect square? Simplifying or reducing the fraction doesn't give a perfect square. Okay, so let's look at it like in this example. We have radical 50 over 6. So we see 6 isn't a perfect square. Let's simplify. Okay, I can take 2 out. Okay, and then I have radical 25 over 3. All right, and so after we take radical 25 over 3, you see that we still have a radical in the denominator, and we cannot have a radical in the denominator of our final answer. We have to now rationalize the denominator. This is our new thing with this, okay? And so what we're going to do to rationalize the denominator is we need to find a way to get rid of this radical in the bottom. When we multiply, to do this, we're going to multiply this by what I like to call fancy 1. Okay? Fancy 1. And the reason I call this fancy 1 is, well, if we multiply something by 1, what we're doing is we're changing how the fraction looks, but you know that multiplying by 1 doesn't change its value. Okay, if you think of any number and you multiply it by 1, it'll be that number. Okay? But, like I said, it's called fancy 1 because we're going to dress it up a little bit. Okay, we're going to, instead of multiplying it and just making it look like 1, I'm going to multiply this thing by radical 3 over radical 3. Okay, now when you look at this, radical 3 divided by radical 3 is just 1, so it won't change the value. Now this is how we come up with fancy 1. Okay, we come up with fancy 1 because a radical is saying, okay, in order to get a number out of the radical, we need a pair. Okay, and so what we're doing is we're going to find the number that makes us a pair. So since this is 3, if we multiply it by radical 3, we get a pair in here. Okay, so in the denominator we'd have radical 3 times 3. In the numerator we'd have radical 25 times 3. Now notice in the denominator now we have this pair, and so now we can just have 3. In our numerator, it doesn't get rid of the radical, but that's okay, because we didn't need it to get rid of the radical in the numerator. We needed it to get rid of the radical in the denominator. Alright? So let's look at number 1. We have radical 7 over 3. I try to simplify it. There's nothing that goes into both 7 and 3 that makes it smaller. So now I have to rationalize this this fraction. Okay, and again, I'm choosing the denominator. The denominator is the number that makes me say, okay, that's what I need to get rid of. So when I do that, I get radical 21 over 3. Okay, and so we have our answer, radical 21 over 3. Okay? Alright, number 2. Or sorry, no radical in the denominator, so we're good. We can stop. Number 2, we have 10 over radical 6. Radical in the denominator, we need to rationalize this fraction. 10 times radical 6 over radical 6 times radical 6 gives us just 6. Excuse me. Alright, so we did that, and now see that we have 10 and 6 here. And so what we're going to do is we're going to try to simplify this fraction. Since 10 and 6 are outside, we're going to simplify this fraction. 10, 6 simplify to 5 over 3. So 5 radical 6 over 3. So we can take 2 out of both of those, right? And so then that's our final answer. Okay. And number 2, why could we not reduce 10 and 6? Because 10 is outside the radical, and 6 is inside the radical. Remember our rule with multiplication and division is inside by inside, outside by outside. Okay? Okay, these can never be combined, or cannot be combined, let's just say that. Alright? You've got these 2 problems, 3 and 4, that I want you to do, and bring in, show me the work for these problems Monday. Or not Monday, wow. Tomorrow. Thanks. See ya. Bye.